Hello and welcome back. We're starting a new section, and in this section I want to talk about some of the basic concepts in C. I want to describe some of the things that we had in our example or our first challenge, our main program here. So I have this challenge up, you probably remember it. It has a number of different statements in lines of code. I'm going to try to cover some of the concepts here. I'm going to go back and forth to this example. The first thing I want to discuss is the concept of a comment. So we'll come back to this in a second. I want to go to some slides at this point. So comments are used in a program to document a program and to enhance its readability. I told you why it's important to have your program be readable because you're going to be maintaining the code and you need to be able to look at it and understand what it's doing. So with comments, it can help quite a bit in this concept of readability. Comments are there to remind you or someone else reading your code what the program is doing or what a particular line of code is doing. So comments are there for your benefit. Comments are ignored by the compiler. Okay, so it doesn't matter if you follow the syntax of comments, the compiler is not going to throw any errors, whatever is inside the comment. So again, they're very useful and you want to use them in your programs. And they're a basic concept of all programming languages. And so there's nothing new really here to see. Again, you may, as a programmer, write some code, come back to it in 6 months, and you may not remember why you wrote the code the way you did. You may not understand the functionality. You may not understand the logic. By providing a comment in the code, it can save a significant amount of time that you waste on relearning things, especially relearning that code. Or imagine that you wrote some code and it's a large program, there's many programmers working on it, and somebody else needs to look at that code. If there's comments in there describing what the code is doing, then that other person is going to be able to understand that code much quicker. It's going to be more readable. So again, comments help the readability. Either they help the readability of the programmer who wrote the code, or they help the readability of somebody else that's looking at code. You can easily look at that source code and then quickly understand what the code is doing. And so you want to provide comments in your code. The syntax for providing comments in your code is there's two ways you can provide comments in your code. And again, this is very, very similar to Java, very similar to many languages. But in C, you can either have multi-line comments or single comments. If you use two characters, the / followed by the asterisk, this will signify a multi-line comment, a comment that spans many lines. And the / marks the beginning of that comment. And when you have these multi-line comments, because they have a starting comment, you have to have something that says it's ending. So to end the comments, you put the characters * asterisk / at the end without any spaces in between. And so then anything in between the / and the ending * is considered a comment. Everything in blue that. And that way you can span multiple lines. The other way that you can add a comment to your C program is you can use single line comments. Single line comments are just two /. Anything after the two / on that line is ignored by the compiler and considered a comment. Anything after that is not a comment. It's a new line of code. So it really depends on the comment that you're providing whether or not you want to use multi-line comments or single line comments. And I'm going to show you how you can add those to your code in a second. Now, as far as styling goes, whether you use multi-line comments or single-line comments, you're probably going to use both depending on what you're trying to do or how many lines you have to describe or how big your comment is. In this example, we're using a multi-line comment here, and this would typically go at the top of the file. It's describing who wrote the file, the author of the file, and then a copyright. You can also provide comments that stand out if something really, really important in your code is happening by providing many asterisks. And so the second example here where it says this is a very important comment is really stands out because of all those asterisks. So it's kind of a different style than the heading comment at the top in the first example. Now the last example here, which is just a single line comment, it's at the end of a line of code and it basically just tells you what a single line is doing. So you see these different styling of multi-line versus single line comments. Here's a common example that you would see in a program. This is a program that contains C code. You don't know really what the heck this is doing, but you could look at the comments and sort of identify what's going on. So there's a comment at the top that says this program adds 2 integer values and displays the results. It's telling you the purpose of the program, what it's doing. And then you see some single line comments. And how do you know they're single line comments? Because they have 2 forward slashes. So you see a single line comment that says declaring variables. You see another one that says assign values and calculate their sum. And then you see one that says display the result. Each single line comment is describing each single groups of code, telling you what they're doing. And so you can quickly look at this code and understand what the code's doing by looking at the comments. It makes the program more readable. Readability is an advantage because it makes the code easier to maintain. All right, so it's important to use comments, and this is a quick example of adding comments to some code. Now, how often should we utilize comments? There is the concept of having too many comments. You don't want to have your code that has a comment for every single line. That actually decreases the readability of the code because it's just overflowing. It's actually making it harder to read because it's just overwhelming. So you don't want to put a comment for every single line of code. You have to choose your comments wisely and use them intelligently. So usually it's good, and this will come with practice. When to add comments, when not to add comments, where to put the comments. Typically, I'll have comments at the top of my source file with standard information like the author, the purpose, the description, the date created. I'll have comments then interspersed throughout my code describing some lines of code where the logic is a little more complicated. I won't technically, or I won't always include comments for just declaring variables because it's kind of obvious. I may not include comments for certain function descriptions because the description itself might be more meaningful. It all depends, and it comes with practice. But whenever you do add comments, it's traditionally a good idea to add those comments when you're writing the code. One, because if you do it then, you'll have the program commented and you won't forget to do it. It's also easier to document the program while you actually understand what it's doing, while you're writing the code. It's still fresh in your mind. You don't have to come back a month later and say, what did I mean here? And now I have to add a comment. So add the comments while you're writing the code. And the comments can also help when you're trying to find and fix your errors during the debugging phase. If there are logic errors, you can look at the comments and you can kind of isolate, oh, well, this is the error that happened. This comment kind of lines up with that functionality. I bet you the error is in this group of code. So it helps you isolate errors in debugging. A comment can help you read through the program, but it can also point the way to the source of a logic mistake. So comments are important. Now, the other argument when providing comments is, again, there's this big debate with programmers. How many comments do you provide? And there is there's a nice book out there called Clean Code, which talks about writing quality code. Believe it or not, code can be good code, or there can be good code or bad code, and that's referred to as the quality of the code. You want to write high quality code. We'll talk about this throughout the course, but a lot of students that learn new languages think, as long as the output matches what I need, it doesn't matter how I write the code. That's not true. Because again, remember that maintenance phase. Remember that the product or the program that you release is going to be out in the field maybe for a number of years. And so if you want to find existing bugs or add new features, it's important that the code is have high quality, easier to maintain, very loosely coupled, highly cohesive. And we'll talk about these concepts as we go through. We're going to be writing high quality code throughout the class. One of the ways to write high quality code is providing comments, but also providing self-documenting comments. And what this means is really using meaningful names. And this is what that Clean Code book talks about. When you create a variable, use a meaningful name. So when you look at the variable, you know exactly what it's being used for. Then you don't need to provide a comment. If you have a function that adds 2 numbers, name the function add 2 numbers. Do you need a comment to say, what is that function doing? No, because the name is telling you what it's doing. So meaningful names is a good way to provide self-documenting comments. Let's go back to our example from our challenge and show you I want to show you exactly how you can add comments and where you add them in. And you'll notice that the compiler is going to ignore these comments. So in our first example here, which is a basic program, I'll typically add multi-line comments at the top of the file before any lines of code. And remember that we can add those multi-line comments by just providing a /** to start the comment, and then anything in between the comment will be the comment. Anything in between the star and the asterisk. And you'll notice when I do that /* that everything turns gray because that's telling me that I don't have my ending comment right now. So you have to add that star / to end the comment, and you'll see that the colors now change. This is why I like to use an IDE, because it tells you a lot with this color coordinated formatting. So anything between the / is the starting of a multi-line comment. Anything in the before the star forward is the description of, or the end of the multi-line comment. And I'll usually put at the top of the file something like author, and I'll put my name. And then I'll put maybe a purpose. This is usually good practice. And I'll put something like, this program prints out my name to the screen. And then I'll usually provide a date of when it was created, whatever the date is. And that's an example of multi-line comment at the top. And then I'll provide comments throughout the code, usually as single line comments or multi-line comments. It just depends how much comments there are. So maybe we're not familiar with this code, and I could say, 2 / is a single line comment, and I can say this code is displaying my name. And again, when I provide these / or these multi-line comments, the compiler ignores them. Basically, you can put anything you want inside there, and it doesn't matter. There's no syntax that you have to follow. There's nothing. It is ignoring everything that is colored gray here that is considered a comment. So comments are a basic fundamental thing of every program. I wanted to describe them early on because I'll be utilizing them, and you should be adding them as you're writing your code. Also, with comments within the IDE, there are times when you're compiling your code and it's all failing. And so there are times when you may want to comment everything or comment blocks of code to try to debug your problem, try to isolate your error. You can highlight multi-lines of code, and then you can go up to the edit in the menu, and you could say comment or uncomment. If you say comment, it's going to comment all of that code that you highlighted. And then you can recompile, and maybe you don't have a compiler anymore. It's a way of isolating errors either at runtime or compile time. So the IDE has some nice tools that allow you to comment multiple lines automatically by highlighting and toggling. Hello and welcome. In this lecture, I want to talk about the preprocessor. We briefly discussed this concept in earlier lectures, mainly just citing it as an advantage. The main reason I want to talk about it a little right now, early in class, is because it's being used in every single program. And I want to talk about the include directive, which is a preprocessor command. So if I want to talk about that, I first have to describe the preprocessor in general. This is going to be a high-level description. As we go through class, we'll talk about more of the preprocessor in terms of its different directives and so on. But to just understand the basics, this preprocessor is a unique feature of C. It's not found in many other languages. And it's very advantageous, and you should try to understand it, and we should try to use it as much as possible. It basically allows for programs to be easier to develop by the developer. It makes programs easier to read. It makes them easier to modify, and it makes them easier to port. So it allows for a lot of advantages. And so to have a description, understand what it is in an early learning of C is important. It's part of the C compilation process, but it's recognized as special statements. And just like it says preprocessor in the name, it implies that something's going on before you process the code. So it analyzes certain statements in your code before it actually analyzes the program itself. It does things before it compiles, essentially. So it's telling your compiler that, hey, before you actually convert any of this code, before you generate the object files, before you generate and do all the linking and generate the executable, first do this. Okay, and so because you do this stuff before you compile, you can optimize things and you can make things a lot easier. Now, you'll often have these preprocessor commands at the very top of your source code, but they can be anywhere. They can be anywhere interspersed throughout your code. One of the big ones that we're going to talk about is the include. So the way that you can identify preprocessor statements in your source code is they have a pound sign before them. So they have that number pound sign. And that has to be the first non-space character on the line in order to be a preprocessor command, also known as a preprocessor directive. Now, as I mentioned, our first challenge actually used a preprocessor directive. It was the include directive. We know it's a preprocessor directive because we saw the pound symbol. We don't exactly know what the include does. We'll talk about that in another lecture, but it is a preprocessor command. It is a preprocessor directive. And again, because it's used so widely, basically in every program, because every program is going to have an include, I wanted to talk about it early on. But it doesn't just mean that there's an include. The preprocessor can do many, many other things and have other commands. Some of the things we'll talk about as we go through this course concerning the preprocessor are things like being able to create constants. Constants is a concept where it's a variable essentially that never changes its value. It's data that never changes. That's how you can think about it, because we haven't even talked about variables yet. But you can create constants in the preprocessor, and this optimizes your code, makes it more efficient and runs faster. There's also this concept of a macro, which is an entire another topic in and of itself, but a macro is another preprocessor directive. And the way that you can create the macros is you can use the define statement. And so we'll talk about the define, we'll talk about creating constants, but you should be familiar with this preprocessor concept and utilizing these different things like include, define, constant. Include, we'll talk about specifically in the next lecture, but a benefit of this is that you can create your own library files. And we talked about what a library is, right? A library is just reusing existing code. So it's code that you don't have to write. The C programming languages comes with its own standard library that does many things for you, like display output to the console, read and write files, handle streams, all sorts of different things. Again, similar, if you're familiar with Java, similar to importing Java APIs, application programming interfaces. Other examples of a preprocessor directive would be conditional things like the if-def, the end-if, the else, or the if not defined statements. And we'll talk about those in more detail as well. But all of these preprocessor directives help with the efficiency of the code. And they run before the compiler actually runs. It's run before any code is generated, any object files or executable files. But we'll cover all this in much more details in future lectures. I wanted to give you a little taste of it beforehand because we need to understand it before we can understand what we're doing with the include statement, which is what we're going to talk about next. Thank you. Hello and welcome. In this lecture, I want to talk about the include statement. And so again, from our first challenge, our first exposure to C code, a C program, you should have noticed this include statement. It's on line 8 here in this example, and this is our example challenge project, basic C program. You see it's include. And now, because we've learned about the preprocessor, we know that it's a preprocessor directive because we have that pound symbol. Anything that starts with the pound symbol before any other spaces is a preprocessor command, a preprocessor directive. And so we know line 8, include, special keyword with the pound symbol is a preprocessor directive. I now want to explain to you what exactly this is doing. What does this mean? Again, this is a basic concept in C that we need to talk about very early on because every C program has it. It's very similar if you're familiar with Java with the import statement. But we're going to describe this in detail now in some slides, but you'll see this in all of your C programs. So the include statement is a preprocessor directive because of that pound symbol. We know that. And we call it a statement as opposed to a directive for no real reason, just because it's common to use that term in programming language. But it is a directive technically. And again, the example in our program was including this something in these angle brackets. So we see this include keyword, and then we see this stdio.h. And so this is an example, and this is the one that we used in our first challenge. It is not strictly part of the executable program. However, the program won't work without it. We know it's a preprocessor directive. It doesn't really do much as far as how the program works. It's just telling the compiler before it runs, hey, we're doing something here with this include. And so if you don't have it there, the compiler is going to complain and throw errors. So you need it. The pound symbol indicates that it's a preprocessing directive. We talked about that, which is an instruction to your compiler to do something before compiling the source code. There are many preprocessing directives, and we gave some examples in our preprocessing lecture. We talked about constants, defined statements. We talked about if and else and so forth, the conditional preprocessing directives. But this is one of the most really commonly used ones, the include. And so Again, these directives can be anywhere in your source code, but they're usually at the top. And the include specifically, this include preprocessor directive is very similar to the import statement in Java, if you're familiar with that. But what does that mean? So in the above example here with the include $stud stdio.h, this is telling your compiler to include some of your program contents of the file with that name. So there's a file name that exists somewhere called stdio.h. And what the directive is saying is, my current program that contains the directive needs some of the contents inside this file in order to compile. So specifically, the include directive is going to have file names that end in .h. These are called header files. They're called header files because they're usually included at the top of the source file. It's one of the first things you do is you include all your header files. And again, this preprocessor directive is saying, I want some of the code, some of the contents inside that file. It's not a C file. We know that files that end in a .c are C source files. So the .h has to be something else. And it is. It's a header file. And it has that .h extension. So let's talk about what a header file is. Header files define information about some of the functions that are provided by that file. And I'll give you an example of some of the content in a header file. But first off, they're defining some information about some source code. And specifically for our example with that included stdio.h, this is including a C standard library header. So remember I told you about libraries. Libraries are just additional functionality that's already written for you in C that you can include in your program so you don't have to rewrite it. So again, examples of libraries are, reading and writing to the console, displaying output, reading and writing files, all sorts of different things, doing networking code, many, many different libraries out there. But stdio.h is a C standard library. What that means is it comes with the C programming language. And it provides functionality for displaying output, among many, many other things. So stdio.h, it's a header file. It defines some functionality that the compiler needs to understand before it can actually use it. So specifically, stdio.h contains information about printf. And so we're going to talk about printf in the next lecture, which helps us display output. But printf is a function that's in the stdio.h header file. And it also contains many other functions. stdio is short for standard input output. So this library is contains functionality for dealing with input and output. And so this is the concept of using a meaningful name. We don't want to call that library JSON or JSON.h because that's not meaningful. We use std.h because it's saying standard IO, standard input and output. And we know that that library contains all sorts of functionality for input and output. Specifically, the functionality that we want to use in our challenge program, our example first program, is we want to use this function called printf, which allows us to display output to the console. And so by including this stdio.h in our source code, we're saying in order to compile, in order to use this functionality, this printf, we need to include this file. So header files are going to specify information that the compiler uses to integrate and utilize any reuse code, any functions within a program. So you're going to either use many, many different standard library header files, and there's many out there. stdio.h is just one. There's again header files that define functionality or function prototypes for networking code, socket code. Again, we're going to go through a lot of them. Strings for complete words and things like that. But in addition to the C standard library and the different libraries that come with the C programming language, you can also create your own header files, and you will be creating your own header files because header files allow for software reuse. They allow you to reuse functionality written in C. So somewhere, the designers of C wrote all this C code that reads and writes data and handles input and output. They don't want this new C programmer to have to write their own, so they're going to write it for you, and they're going to say you can use it. And the way that you use it is you include the header file. And so you as your own developer, you may write some code in a big, large program, thousands of files that you want to be used in other files. And so you'll write your own header files. And the header files, again, are going to define function prototypes, different constants, all sorts of different things that are going to help another file that can use your program. It will help compile your program. So it's a software reuse technique essentially. So we're going to include this standard io.header file in a program whenever we need to use the printf function from the standard library. It's required. If you didn't include it, it will not compile. So whenever you're using certain functionality, you have to use the include. The syntax, as far as header files go, they are case sensitive. Case sensitivity means uppercase or lowercase. It matters whether you do one or the other. So you should always write them in lowercase. Your header files should be in lowercase, because otherwise certain systems may interpret them as different, have a different meaning. There's two ways to include header files in a program. You can use angle brackets, such as #include JSON.h in angle brackets. And what this usually means is it's telling the preprocessor to look for a file in some kind of system directory. It's usually a standard library that comes with the C programming language. You can also use double quotes. Double quotes usually means it's a user-defined header file. It's one that you created as a developer that didn't come with the C programming language, but you want to have that header there because you want to reuse some code. So it's also going to say look in the current directory. Every C compiler that conforms to the C11 standard will have a set of standard header files supplied with it. These are just header files that represent libraries. C functionality that comes with the language. You can also, when you do use the include directive, it's common practice to use the other preprocessor directives, if not define and define, so that you don't include the file more than once. This is for efficiency. So if your program is using printf, for example, displaying output to the screen, you want to tell your program, hey, I need to include this additional functionality in the standard library. You don't want to tell it to include it more than once, because it becomes, the preprocessor will do many things that it doesn't need to do. So typically you'll use if not defined. So you'll see some of this in some of the examples that I provide, where I wrap the includes in these if not defines and define statements. Here's an example of a header file and its contents. You may have some header file has some comments in it. It could have other things in it. It mainly has function prototypes in it, but it can have constants. It can have type defs. These are some concepts that we don't understand yet, but I'm just trying to illustrate, trying to help you understand that it contains many different things. But again, for our standard library inclusion, standard io.h, there's something in there called printf that defines the printf function, so that when we link, we can find the implementation code for that. So here are some function prototypes. Function prototypes are just names of functions. We know what a function is, hopefully by now. It's just a way of grouping code together. We'll talk about functions in much more detail later. So a header file can include many, many different things. It can include defined directives, constants, structure declarations. This is, again, kind of a way to group different variables, group different data. Type def statements have to do with data types. We'll talk more about that. But function prototypes are really the important one. They're telling you how functions are defined so the compiler can generate the code it needs to. Executable code, remember, goes in a source code file. A source code file ends in the .c extension. Executable code normally doesn't go in a header file. There are some exceptions when you want to do things inline, which is, again, an efficiency thing where you can put source code in header files. But typically a .h file, a header file, is not going to contain implementation code. It's going to contain lines of code for just definitions. All right, there's not going to be any logic in there. It's just going to be definitions. This function exists. That function exists. These constants exist. These different structures exist. They don't say how this code is doing what it's doing. It's just telling you that it's there. It's needed by the compiler to generate the linking. Okay, so you're going to create your own header files. You're going to use system header files for additional functionality. It's a concept that you need to understand before you move on with writing C programs, because you're going to see this include directive in all programs. And it's just telling the program, again, that we're including an additional code somewhere. We're including additional definition code so that we can now invoke these different functions and this different code in our C program. So I hope that makes sense. It's not a real complicated concept. We're including additional code. It's pretty intuitive, but we'll go through it and we'll provide more examples as we go. Thank you. Hello and welcome. In this lecture, I want to talk about how you can display output to the screen. So here I have our example program that we started out with. And our first challenge was to display output to the screen. And so after you look at this code, you probably noticed on line 13, which is our printf, this is the code that's actually displaying the output. And again, this is a basic concept of C that needs to be addressed very early on because you often need to display output to the screen. So let's talk about displaying output to the screen using this printf function. Displaying output. So again, I just mentioned this. You should have noticed that printf line in our example program, our first challenge. It's included the word printf. And you probably thought to yourself, well, what does this mean? What does this do? Well, now I want to explain it. It basically displays output to the screen. It's a standard library function. And what are standard library functions? We talked about this quite a bit, but it's a function that comes with the C programming language that you can utilize to display output. You would not want to write your own code to display output to users because it's a very common thing that you do in your program. So you wouldn't want to have to write that every time. So what you do is you use that include directive. You include the standard library header, which defines that printf function, which allows you to display output to the screen. Printf specifically is going to output information to the command line. The command line is also referred to as the console or the terminal. But by default, it's actually displaying the information to the standard output stream, which is the command line by default. That's why you see it there. So you'll see it in when we run our programs, and we saw that little black box, the DOS command prompt, the command line. That's where we saw our output, because that's where printf is directing it. We're saying display this output on the console. The information displayed is based on what appears between the parentheses of the function itself in the double quotes. So everything inside those double quotes is going to display. Now the printf function itself can get much more complicated using format specifiers, which we're going to discuss later. But basic information is you just print out words and text. And anything in between those double quotes is going to be displayed to the output. The other important thing to notice here, and I mentioned in a previous lecture, is it's a statement, so it's going to end in a semicolon. The semicolon tells the compiler, we're done, we're printing this information, now we're completed printing that information. So the function itself, it's probably one of the most common used functions in C because you often need to display output. It will be the function that we use most in this class because you can use it for many, many things. Now, so far in our example first program, we just displayed some text, some output to the screen. But it's very easy, it's very convenient to also display program results besides just text inside quotes. You can also display values of variables and the results of computations. So what this means is it can be used for debugging. It can be used as a technique to display values of variables in your program while it's running. You can also use it to see where you are in your code as you're executing. And this is one of the reasons I wanted to cover it so early, because we're going to use it as a debugging technique so we can see what's going on in our program as it's running. And we're going to use it to display just regular words and results of programs. So it's very, very useful to understand how to display output to the console using this printf function. Again, the basic way to use it is just to include everything in the double quotes, but we'll provide many examples of this. I just wanted to tell you, hey, this printf, this is what it's doing. It's displaying output to the screen, and we're going to be using it quite a bit, especially for debugging. Thank you. Hello and welcome. In this lecture, I want to talk about reading input from the keyboard. This is a basic concept that I wanted you guys to learn early because it's very valuable, and a lot of programs take input. So I provided this early on. Some of the concepts are not going to be completely clear, but we'll definitely learn these concepts in other sections as we go through. But it's important to learn this very early. And it's very similar to the printf function. So we've discussed output. We know how to format output using printf. We now have to learn a little bit about input, getting input from the user essentially. It's very useful to ask the user to enter data into a program. We talked about command line arguments, entering data via that way. That's one way to do it. Another way is to ask the user directly so that they can type something in the keyboard. So you get the input from the keyboard but it gets displayed. You enter the input via the terminal of the console. That's how you enter the input. The C library contains several input functions. We're going to use scanf. That's the most generic function. It's very useful. It provides the most different formats that you can enter. So you can enter text and then it will get converted to the different formats. So scanf reads the input from the standard input stream. That's standard in. Scanf can actually be used for reading from files as well, if the input stream is a file. But we're not going to worry about any of that for now. We're just going to use it to read input from the keyboard. Okay, and so standard in by default is the keyboard. Standard in is a stream. Streams in C, there's 3 different streams: the error stream, standard in, and standard output. Standard in by default is the keyboard. So we're going to keep it that way. And using scanf, it's going to read from standard in, and then based on what you enter, or how you want to store the data, I should say, it's going to convert what you entered, because what you enter is going to be text. It's going to convert that text to the format that you provided. So it's going to use format specifiers, just like the printf function. So the format can be a sequence of characters, which is called a string. We haven't studied that in a lot of detail yet, but again, we will when we talk about data types. And then also you can specify other data types that we're going to talk about, such as integers, numbers, basically. So you can read numbers, you can read strings, you can read numbers that contain decimals, single individual characters, all this nice stuff. If the standard is input from the keyboard, which is default, what's going to happen is as you type in text via the keyboard, it's going to take that text, put it into the C program, and it's going to convert that text. And text is things like letters, digits, and punctuation. So even though you're typing in a number, it's still text because it's coming from the keyboard. So if you enter the integer 2014, which is a number, and you type you're essentially what's happening is you're typing characters 2, 0, 1, and 4. And what will happen is it will send that input to the C program. And if you want to store that data as a number, then you're going to have to convert that data. And so you have to specify the format specifier how you want to convert it, just like you do in the printf. Remember, like with printf, you use %d to print an integer. You would convert the text to an integer using %d as well for scanf if you wanted to convert the string to a number. And that's what we're going to do for basics early on. We're just going to use numbers because we know numbers so far and we haven't really learned about strings yet. So we're going to mainly use numbers when we input. So scanf, it's very similar to printf, but instead it is a little different in certain arguments that it takes. It still uses a control string followed by a list of arguments. So there's going to be something in those double quotes. The double quotes typically will only contain one thing, and it will be the format specifier, how you're going to convert the data. So the control string indicates the destination data types for the input stream of characters. It's that format specifier. %d, %c, %s, %f for float, and so forth. The printf function uses variable names, constants, and expressions in its arguments, right? Because we learned that. You have something in double quotes, and then inside the double quotes, you use format specifiers, and then after the commas, you can print out variables, or you can even print out expressions. Expressions we'll talk about in more detail as well, something that essentially returns a value. Most common type of expression is an arithmetic expression. The scanf function is different because instead of actually displaying variables, it's going to use variables that are pointed to. But luckily, pointers is a big concept in C. You don't have to know anything about pointers in order to understand and use the scanf function. So don't worry about that. All right. All you have to do is you have to remember 3 rules about the scanf function in order to use it. It's going to return the number of items that it successfully reads. So this is, if it reads 1 variable, 2 variable, 3 variables, it will return that. If you use scanf to read a value for one of the basic variable types that we're going to discuss, such as the int, the float, the double, then all you have to do is the variable name as the argument has to be preceded with an ampersand. Right? You don't even need to know why that is right now, but just do it. Any of the basic data types. Ampersand is address, and because scanf takes a pointer, you have to dereference, you have to pass in the address. The third thing that you have to remember for scanf, if you use scanf to read a string, which is a sequence of characters, into a character array, you don't have to use the ampersand. So basically, scanf takes 2 arguments, which I'm going to show you an example. The first argument is going to be how to convert the data that you type in. And if you store that data in int, you use format specifier %d. If you want to store it in a string, which we haven't learned about yet, you use %s. And then the second argument is and it could be many arguments depending on how many format specifiers you use, because just like printf, would be the actual variable, the variable name. And if the variable is everything but a string, you just use the ampersand. Otherwise, you don't use the ampersand. Scanf function also uses whitespace to decide how to divide the input into separate fields. And whitespace includes new lines, tabs, and spaces. And again, I'll go through an example to show you what that means, because just like printf can display many, many variables, depending on how many format specifiers you have inside the single quotes, same thing with scanf. If scanf has multiple things inside the double quotes, it will read multiple inputs, and the inputs are going to be divided by new lines. So again, scanf, if you want to try to understand what scanf is, it's the opposite of printf, right? Printf is going to convert integers, floating point numbers, characters, strings, all these different data types, and it's going to convert it to text so that you can see it output. And it's going to be displayed on the screen. Scanf is the opposite. It's going to take as input text and convert it to any of the different data types like ints, floats, and doubles. So let's look at an example. This is an example of a simple program. We know what the main routine is. We know what the include directive is. We haven't learned about characters and integers yet, but basically at the very top of that main function, we're creating two variables because we need to store the data. And we're going to talk about variables in much more detail. But just like the printf function, again, you're just doing the opposite. So here we're displaying output to the screen saying enter a value. Scanf inside the double quotes has format specifiers to read in the input. And so you have to specify the data that's going to be read in. Here it says %s%d. What that means is we're reading in a string, then we're reading in an int. And you'll notice that the string doesn't have the ampersand in the scanf after the first comma. And after the second comma, we have an ampersand because that's an integer. We're reading in a number. And then the printf is displaying output. So it's saying you entered in this string in this integer, just like we know what printf does. And then the main function returns a 0. All right, so let's go through this example in a second in code blocks, but let's just, again, reiterate a couple concepts. When a program uses scanf to gather input from the keyboard, it waits for you to input some text. So the program is actually going to pause until you enter the data. And then once you enter some text, and if you enter some white space, if you're entering in multiple things, then the program proceeds and reads the input. Once you actually hit the enter button, you have to hit the enter button. Again, scanf expects input in the exact same format that you provided. So if you say %s and %d, that means you have to provide a string followed by a space, any number of spaces, followed by an integer, a number, and a word. Right? String is a word, integer is a number. So let's go through this example line by line in code blocks. Okay, so here we have our main function. And again, it's important to be able to enter data into a program. So just like the printf, it's going to be very similar. And we don't have to understand all of this code. And we'll even get rid of the parameters that are being passed. It's a simple main function. We don't have to understand all this code. We don't even have to understand what variables are at this point. But variables will store data. In the example, we're creating a string array of 100. And with a semicolon, and then we're also just going to create an integer. Just like in printf, we have an integer, but we're using a string. I just want to demonstrate different inputs. Then, usually before you call the scanf function to get input from the keyboard, you're always going to tell the user something. You want to tell them what to enter. So printf, remember, displays data to the screen. We're just going to say enter a value. And they're going to actually enter a couple. And then we end it with a semicolon. We have to tell the user to enter something. Now here's where we use the scanf function. We say scanf, and then inside the parentheses, the first argument inside the double quotes is going to be data that we're going to read. So in this example, let's just say we're only going to read one input, %d, which is an int. And then we're going to store that data in a variable because we want to look at it, and it's going to be I. Now we have to specify the ampersand before that because remember this little trick with pointers. You don't have to know why, it's just the address. So that scanf on line 17 is going to actually read data from the keyboard until the user hits the enter button. And then that data is going to be stored in a variable called I. So now we just want to print what we entered. So here we're just going to say, we're going to add a line feed so it's readable. So we're going to use our escape sequence \n, and we're going to say you entered %d, and we're going to display the value of the variable. And we're also going to put a line feed after. So the value of the variable that we want to display is I. We're going to end it with a semicolon, and then that's our program. So again, printing output, asking for a value, reading input line 17, specifying that the data that we're reading is an integer, storing it in I using an ampersand, and then printing out what we just entered. So let's build this and let's run it. And you'll see the program starts and then it pauses because it wants you to enter a value. It says enter a value. So at this point, I have to enter a number that it can convert to a string, right? Because that's what's happening. So here, I'm just going to say 56, right? And then I'm going to hit enter. It ran twice because of my virus scanner. So just, I'm going to say 56 and then enter. And then it prints out I entered 56. So I was able to enter information, number, and it stored it in a variable. Now, as just like printf, you can actually have them enter multiple things and store in multiple variables. So here, after they enter an integer, I'm going to say another percent format specifier, %s, which means I want them to enter a string, which is just a word. So here, remember, if it's a word, I don't have to provide the ampersand, so I'm just going to say stir. I want to store that data in the variable store. And again, we'll learn about variables. And then I'm going to just print it out. And I added another variable, so you know that printf, and I'll just put colons before it. You also have to specify the format that you're printing. So there, %s. So hopefully that's clear. I'm now going to read in two inputs separated by spaces, store them in two variables, I and stir, and then display them. So now if we build and we run, so here I'm going to enter a number, 22. I'm going to hit space, and then I'm going to enter my name. And then I'm going to hit return. When I do that, the program is going to unpause, and it's going to display the number I entered and then the string. So it displays 22 in JSON. So this is how you can get input from the user. Simple, 4 or 5 lines of code. And again, this is useful because some of our challenges will want you to get input from the user. And in order to do useful things and learn different concepts, we should be able to get input from the user. So I hope this helped. And again, don't worry about some of these concepts that you're not fully understanding, things like variables and strings. We're going to discuss all that in a lot of detail. Thank you.